So students, welcome to the session. So in this session, we will discuss about a new notion that is known as determinant. Actually, in the last session, we discussed about matrices. The portion of matrices can be divided in two categories only for your convenience. In one portion, we discuss about addition, subtraction and multiplication of matrices, and the remaining portion of the matrices is based on a new notion, that is determinant. So before proceeding the remaining portion of the matrices, first we should understand the concept of the determinant, which will helpful in the subsequent texts in case of matrices. So the determinant of a matrix is a single numerical value that provides important insights into the properties and behavior of a matrix it represents. For a square matrix, the determinant can indicate whether the matrix is invertible or not. Invertible matrix we will discuss later in the remaining portion of the matrices. Invertible matrix is that matrix whose inverse exists. You know, in case of numbers, if we have a number 2, for example, then what happens? 2 is a number. We can always find out a number 1 upon 2 such that if these two numbers are multiplied, then its product is 1. So 1 upon 2 is called the inverse of 2, right? In the same way, in the subsequent text, we will discuss how the inverse of a matrix exists, right? So determinant will help you to identify whether a square matrix is invertible or not. So for every square matrix A of any order, so throughout this session, the matrices are considered as square always. We will not consider rectangular matrix. I may speak square word or may not speak, but it is understood that the matrix considered is always square. Either its order is 2 or its order is 3. So for every square matrix A of any order, we associate a number called a determinant of A, and it is denoted by either this notation or this. Determinant of A we will denote like this or like this, right? If a matrix is not a square matrix, we cannot associate a determinant with it. So what does it mean? It means only square matrices are characterized with the help of the new notion which is known as determinant, right? The determinant of a square matrix A of order n is written as like this: A11, A12, A13, A1n, the first row, A21, A22, A23, second row, then A31, A32, in this way. So the elements of a determinant are written verbatim as it is without any change as the elements of the matrices are written. The difference is what? We will enclose all these elements within two parallel lines like this. This is the notation of determinant, right? And this is the notation of matrix. This is the basic difference, right? So how the determinant is defined? Before having the formal definition of a determinant, let us have a look of the basic distinction, basic differences between determinant and matrices. A number of differences are there, but for your convenience or for your satisfaction, I have taken only few to make you the things clear. Aspect 1 is what? Definition. So as far as the definition of the matrices is concerned, matrices may be rectangular or it may be square. In case of determinant, determinant is always a scalar value. A scalar value means the value of a determinant is always a number. The second aspect is what? Structure. As far as the structure of the matrices is concerned, it consists of multiple rows as well as columns. On the other hand, in case of a determinant, it's a single numerical value. Dimension, the size of a matrix is m by n, means it may be rectangular or it may be square. But in case of a determinant, it's always square means number of rows and columns both are same. Purpose, use in diversified areas. A number of areas are there where matrices are used, and determinants are used to characterize the invertible property of the matrices, whether the matrix is invertible or not, and it can also be used in finding area and volume of the various geometric figures. Invertibility, matrix may not be invertible. Every matrix is not invertible. But what about determinants? It indicates whether the given matrix is invertible or not. Clear? So these are the basic distinctions or differences in between these two notions, matrices as well as determinants. So determinants in fact characterizes the various properties of the matrices, right? Let us have the formal definition of a determinant. Let A is equals to A11, right? Highlighted by the red color. Look at this. A11 be a 1 by 1 matrix. Before proceeding it, I have told you if I write it like this A11, this A11 is simply a number, right? 5. 5 is a number. But if I write like this A11 in this or 5 like this, do you know the difference between these two terms? Here A11 is simply a number, but here this A11 is a matrix having one row and one column, and this A11 is considered as an element of the matrix. Right? Likewise here this 5 is simply a number, but this 5 represents a matrix having one row and one column, and 5 itself is considered as a element of the matrix, right? So let A is equals to A11 is a matrix having one row and one column. Then its determinant, for example, A is equals to A11. This is a matrix having one row and one column. Then its determinant is written like this. Determinant of A is equals to A11 will remain as it is, but it is enclosed in between these two lines like this. I have told you the elements of a matrix will remain the same. So in this case, this is a matrix, and in this case, this is a determinant, and its value is itself a number A11. So if we have a matrix of order 1 by 1, its determinant can be written like this. The determinant is equal to element itself, right? Now we will start from here. Say if A is a matrix of order 2 by 2, for example this. Clear? Then how we can write its determinant? Its determinant can be written as determinant of A is equals to the elements of the matrix will remain the same. A11, A12, A21 and A22, right? And enclose them in between these two parallel lines. Clear? So this is a determinant associated with the matrix A whose order is 2 or 2 by 2, right? Now after writing down a determinant of order 2, here in this case, this is the determinant of order 1 and the value of the determinant is A1 itself because it contains only one element. But here the determinant contains 4 elements A11, A12, A21 and A22. We will have to find out its value, and the value of a determinant of order 2 is simply obtained by multiplying the first diagonal minus the second diagonal. That is, multiply these two first minus these two first. Clear? So determinant of A is written like this. Its value is A11 into A22 means these two elements multiplied first minus these two A21 into A12. This is the value of a determinant of order 2. For your satisfaction or for your convenience, let us take a determinant of order 2. Say A is equals to 1, 3, 2, 4, 9. For example, this is a determinant. So how we can find out its value? Its value is simply obtained by multiply these two elements, that is 3 into 9 minus multiply these two, that is 2 into 4. So this is what? 27 minus 8, you will get 19 is the value of the determinant A, right? This is the value of determinant A. So A is equals to this is called the determinant of order 2. The value of a determinant of order 2 is obtained by taking the product of the entries in the main diagonal and subtracting from it the product of the entries of the other diagonal, right? Main diagonal means this is the main diagonal, 3 into 9, and then subtract it from 4 into 8, that is from the other diagonal. Take this example, 2, 4, 1, 3, this is a determinant of order 2, so its value will be what? 2 into 3. This diagonal minus 4 into 1, so 2 into 3 minus 1 into 4, this is 6 minus 4, that is 2. Clear? Likewise, take this case also. This is a determinant xy minus y and x. So multiply these two, x with x, you will get x square, minus multiply these two, minus y into y, so minus minus plus, you will get y square, so x square plus y square is the required value of the determinant. So this is how we can calculate the value of a determinant of order 1 or a determinant of order 2. In a similar way, we can also calculate the value of a determinant of order 3, but before proceeding calculation of the value of a determinant of order 3, you must ensure yourself whether you understand the concept of how we can determine the value of a determinant of order 2, because it will play a very prominent role throughout the chapter. Simply, whenever you have a determinant of order 2, you can calculate its value by multiplying the first diagonal minus product of the second diagonal. Clear? Let us take an example of a determinant of order 3. For example, this is a matrix having 3 rows and 3 columns. Clear? So step 1 is what? Write down its determinant. Look at the elements of the matrices as well as the elements of the determinants. Elements remains the same. We are not changing even a single element, right? So this is the determinant. Simply this bracket is being replaced by these two lines. This is the only difference, right? So this is a determinant of order 3 and its value can be calculated as this is called a determinant of order 3 associated with the matrix A, and its value is given by this formula. Look at this equation. See, whenever we have a determinant of order 3, we can find out its value by decomposing a determinant of order 3 into sum of the we can find out the value of a determinant of order 3 by decomposing it into sum of the determinants of order 2, right? See, how does it happen? Second thing, we are having 3 rows and 3 columns in this determinant. So we can expand the value of a determinant of order 3 is calculated by expanding it along any row or any column. So here in this example, we have 3 rows and 3 columns. So we can expand the given determinant along the first row, second row, as well as third row, or along the first column, second column, or along the third column. So total number of ways this determinant can be expanded along 3 rows and 3 columns are 6. Clear? So in all the 6 ways, the value of the determinant will remain same in each case. This you should keep in your mind, right? For example, here we are expanding this determinant along its first row and see how it will happen. We are expanding the determinant along the first row. So this is the first row. A11, A12, A13, they are the three elements. See what we can do. Take the first element A11, right? After taking first element A11, delete the row and column in which A11 lies. So A11 lies in the first row and first column. What is left? It should be multiplied with A11. What is left? A22, A23, A32 and A33, right? Clear? Now come to element 2, A12. We will use plus sign with the first element, then minus sign with the second element, then again plus sign with the third element. So plus, minus and plus, it means we will use alternate sign. So we have used the plus sign with the first element. Now with the second element we will use minus sign, minus A12 into. Use the same approach, delete the row and column in which A12 lies. So A12 lies in the first row and in the second column. What is left? A21, A31, A23 and A33, right? This is the value of the second element. Now what is the third? The third element is A13. Again we will use plus sign, so A13 into. The same approach, delete the row and column in which A13 lies. So A13 lies in the first row and third column. What is left? A21, A31, A22 and A32. Clear? This is actually this row. We have shown this row, right? This is called the expansion of a determinant of order 3 along the first row by decomposing it into some of the determinants of order 2. So this is the process which we can use along any one of the three rows or any one of the three columns. So total ways are 6 to expand this determinant, and in all 6 ways the value of the determinant will be 0. Now if you obtain this equation, now finally this is a determinant of order 2, this is also a determinant of order 2, this is also a determinant of order 2, and you know how we can find out the value of a determinant of order 2. Multiply these two elements first, minus these two. Here multiply these two elements minus these two, and then multiply these two elements minus these two. Substitute all these values and finally you will get the final value of a determinant of order 3 we have considered. Clear? Let us take the same way. Rule for expanding the determinant of order 3. We have seen that this is a determinant of order 3. This determinant can be expanded along any one of the three rows or columns. We have expanded it along the first row. See A11. Delete the row and column in which A11 lies. So this is left. Minus A12. Delete the row and column in which A12 lies. You will get this, plus A13, delete the row and column in which A13 lies, right? So this way you can expand the determinant to find out its value, but we will use the plus sign with the first element and then minus sign with the second element and then again plus sign with the third element. So we can expand the determinant by means of any row or column. In expansion of a determinant, we write the first element of a row or column with proper sign and multiply it by the determinant obtained by deleting the row and column in which the element lies. We continue this procedure till all the elements of that row or column are exhausted. Clear? So this is the best way to find out the value of a determinant of order 3. Clear? Now let us take the practical examples for your clear understanding. See, we have taken in example 1 two cases. Case 1, evaluate this determinant. by expanding it along the first row. And in case 2, evaluate this determinant by expanding it along second column, right? So case 1 is what? This is our determinant, right? We have to expand the determinant along row 1. So row 1 contains 3 elements, 1, minus 2 and 3, right? Clear? So take element 1 first. 1 is here, right? Delete the row and column in which 1 lies. What is the rule? We are expanding, be careful, we are expanding this determinant along the first row. The first element of the first row is 1. So we have written 1 here into. Delete the row and column in which 1 lies in the first row and it lies in the first column. Minus 1, minus 2, 1, 5. So we are getting this value. With second element, we will use minus, right? So minus this, and minus 2 is already there. So minus 2 we will get here plus, okay, right? So minus 2 into, delete the row and column in which minus 2 lies. So it lies in the first row and in the second column. 4, minus 2, and 5. We are getting this determinant. Plus, last element is 3. So same way we can find out 3 into, delete the row and column in which 3 lies. So 3 lies in the first row and third column. What is left? 4, minus 1, minus 2 and 1. So we are getting this determinant. So what we did, we decomposed, as I have stated, we decompose this determinant of order 3 into sum of the determinants of order 2, because we have a very simple formula to calculate the value of a determinant of order 2. Now you can calculate the values of this determinant. This is a determinant of order 2. So 1 into minus 5, that is minus 5, minus 2 into 1 is minus 2. So minus minus plus, so minus 5 plus 2, you will get here minus 3. Clear? Here 2. 4 into 5 is 20. Minus minus plus 2 into 2, 4. So 20 minus 4, you will get 16. 16 into 2, that is 32. Third, 4 into 1, that is 4. Minus 2 and minus 1 is minus 2. So 4 minus 2, you will get 2. 2 into 3, that is 6. Sum of these all, you will get 35 as the value of the given determinant, right? Similarly, you can expand second case along second column. Second column means this. 2, 5, minus 1. See, in the same way, this is 2. Delete the row and column in which 2 lies. So 2 lies in this row. 1, 0, 6, 7. This. Second thing is what? 5. 5 lies in the second row and second column. What is left? 3, 4, 6, 7. This same. And what is third? Minus 1. So minus 1 in the lies third row and 3, 4, 1, 0. 3, 4, 1, 0. This way. Simplify these. You will get 33 as the value of the determinant. So by these two examples, we observe that we can expand any determinant of order 3 along any one of the 3 rows or columns. So students, I will advise you, these two examples, we have expanded this determinant along the first row. You can expand it along the second row, then third row, and finally along the first column, second column, and third column. In the same way, you can also find out the expansion of this determinant along any other the remaining rows as well as columns, right? This is also another case to find out the value of a determinant of order 3, which is known as the Sarus diagram for expansion of a determinant of order 3. If you are not comfortable in method 1, then you can use method 2, right? So here given below a diagram known as Sarus diagram, which helps us to calculate the value of the determinant of order 3rd very conveniently. See what is the approach. This is our matrix, right? Say this is a determinant. We are taking the determinant directly. Let A is equals to this determinant. then we can represent the elements of a determinant as follows. So what Saras did actually, this is a determinant of order 3. So we will use like this, say A11, A12, A13. They are 3 elements, and we will repeat the 2 columns again, that is A11 and A12 again. This is column 1, this is column 1, this is column 2, and this is column 3. Write down these 3 columns as this, and this. And then first 2 columns should be repeated again. This is again column 1, this is again column 2. Write down a matrix in this form. I will show you by an example in the next slide. So see A11, A12, A13, then the first column A11 and A12 is written like this. Repeat the same process for the whole determinant. Here, this element in this way, and finally after writing down 5 columns in place of the given determinant which is having 3 columns, right? The remaining elements also should be written like this: A21, then A31, this is A22, this is A32, this is A23, and A33. Here again A21, A31, and A12. This is A22, and this is A23, right? After writing down a determinant in this form, what we have to do? We have to use the cross multiplication process. Use this way, make the diagonals, right? The first diagonal is what? The first diagonal is A11, A22, A33. This is your first diagonal. So A11 into A22 into A33 plus, this is your second diagonal, A12 into A23 into A31, and this is your third diagonal, A13 into A21 into A31 into A33. So this into this plus this into this, right? Minus, the diagonal should be reversed, this plus this into this, and minus this into this into this, minus this into this into this, right? So what actually Saras given? A determinant is containing 3 columns. In place of 3 columns, write down a determinant having 5 columns. First 2 columns should be repeated, and then take the diagonal elements, first diagonal in this way first, minus the second diagonal in this way first. Simplify this, and when you will simplify, this will be the value of the determinant. So if you wish, or if you are comfortable, you can also use this method to find out the value of a determinant of order 3. Let us take an example for your understanding. Let A is equals to this. See this. This is a determinant containing 3 columns. This is column 1, this is column 2, this is column 3. So what Saras did? In place of the 3 columns, we will write down a determinant or a data having 5 columns. First and second columns are being repeated. See, 1 2 1, sorry, 7 2 1 column 1, 4 3 5, 4 3 5 column 2, 2 8 6, 2 8 6 column 3, right? These are the initial 3 columns what are given in the question. And then after, what we will do, we will repeat column 1 and column 2 again. So 7 2 1, 7 2 1 column 1, 4 3 5, this is column 2. So in place of 3 columns, we will write down 5 columns. And after writing down these 5 columns, what you have to do, use the concept of the principal diagonal. See, 7 3 1, this is the first diagonal, right? Okay, 7 3 1, this is the first diagonal. So 7 into 3 into 6, right? 7 into 3 into 6 plus, this is the second diagonal, 4 into 8 into 1, 4 into 8 into 1 plus, this is the third. 2 into 2 into 5, right? 2 into 2 into 5. Clear? All the three diagonals we have multiplied. Minus, now come to the second way. Start from here. This is the first diagonal. So 1 into 3 into 2. 1 into 3 into 2 minus. This is the second diagonal. 5 into 8 into 7. So 5 into 8 into 7 minus third is 6, this one 6 into 2 into 4, 6 into 2 into 4. Clear? And when you will simplify all these things, the product of these two is coming out to be, simplify it, it is coming out to be minus 156. So this is also another way to find out the value of a determinant of order 3. This method is given by Saras. That is why the approach or the method which we are using is known as the determination of the value of a determinant using Saras diagram. Simply, in case of 3 columns given in a determinant, we will write down the 5 columns by repeating column 1 and column 2 again, and then use the first diagonal elements first, this into this into this, plus this into this into this, plus this into this into this, minus this diagonal, this into this into this, minus second diagonal, this into this into this, minus third diagonal, this into this into this. And then you can simplify it. What else you will get, that will be considered as the value of the determinant. Here it is coming out to be minus 156. So students, this is all about the determinants. I have told you the concept of the determinant is very important to understand the remaining concept of the matrices which we will discuss in the subsequent text, because they will characterize the basic properties of the determinants, like determinant is invertible or not, and inversion of the matrices play a very prominent role in the practical areas. That's why the concept of determinant is very important. So thank you very much. It's all about calculation of a determinant of order 2 and order 3. Thank you very much.